Hello, everyone, and welcome to Science Expeditions. I promise you a good time, especially if you pay attention and also think about what I'm going to share with you and also do some of these experiments on your own, both now and afterwards. I'm very happy to be part of this event, and I want to tell you that we all obey the safety rules. And one of the most important safety rules is right now is to wear masks if we are with other people who are not family members. I'm here by myself with my little dog. Can you see my little dog down there? You can see my little dog. I hope he stays quiet. Usually he likes to participate in the presentation, but we'll see how that goes. So on my next slide, I want to show you an experiment that we do in the lab or we do in a big program. We cannot do that experiment today because we obey the safety rules. But that's an exciting experiment. It's part of my Once Upon a Christmas Cheery in the Labo Shakhashiri TV program. It's on PBS. Actually, if you go to my website, scifun.org, scifun.org, you can click and watch it, but don't do it now because we are about to start doing some experiments here. Next slide, please. So here you see people paying attention. This is when we were doing experiments in a variety of different settings. And always pay attention to what goes on so that you can learn. And you can see the smile and the intense concentration of people of different ages doing these experiments. So my next slide starts by asking a question. Do you always believe what you see? Do you always believe what you see? Well, if you come full screen to me now, Bia, I'm going to do an experiment and ask you to help me do this experiment too. So you take a piece of paper and draw two arrows on it, just like that. I have done this before, so I don't take too much time doing it. So draw two arrows. They're separated like so, okay? They don't have to be red. They can be any color. They can be black, whatever it is. All right. After you do that, then you take a glass of water. A glass of water. You see it is about 80% full. You do that. And then what you do, let me just switch hands here. I'm going to hold the glass of water up here. Can you see that? And can you see the two arrows? All right. So now I'm going to I'm going to bring the arrows up. You see the two arrows? You see what happened when I can see it on your faces. You're smiling. You can see that something has happened. So try it. Do it yourself. Yeah, no. But you put the paper in front of you so you can see it. So you can see that the arrows, at least the one that is higher, has switched directions. So I want to ask you to think about why that happens. I say that probably all of you know from experience in the summertime, when you're at the swimming pool and you put your leg in the water, you notice, are you beginning to remember what you noticed? That your leg is not straight. So always think about the observations that you make and try to make some sense out of them, because there are sometimes illusions that we experience. Now, one of the most beautiful illusions that we all like, we all enjoy, is the rainbow, the colors in the rainbow. You know, the rainbow is not real. There is no real thing out there, but it is the result of the interaction of light with matter, and then it is a result also of what we perceive in our brain. So it's very important that you do that. We learn from the senses. We learn by seeing, by hearing, by touching, by tasting, by smelling. So this was just an experiment that has to do with the visual with visual perception. So now I want to describe to you an experiment. We're not doing it right now, but if you pay close attention, you can do it later on. If you take 3 glasses, 3, I only have one here. Take 3 glasses. One has water at room temperature. Another one has ice water in it. And the one you put on the other side has warm water, not hot water, not very hot water, just warm water. And the experiment that you do is you take one finger and you dip it in the glass that has the warm water. You dip the other finger in the glass that has the ice water, and you will be able to feel the different the temperatures. And then you take both fingers and dip them in the glass that is at room temperature and see and feel, not only see, feel what is going on. So we always have to rely on our senses to give us information that we process and we think about. All right, now here's another experiment that we can do right now, especially if you have the rubber bands. Do you have any rubber bands? Okay, so take the rubber bands here. I have 3 rubber bands together. I bring them close to my forehead. I'm going to turn around so you can see what I'm doing. Can you see what I'm doing, or am I blocking? Like that, yeah. So what I do, I put the rubber bands on my forehead and I feel, well, they feel like rubber bands. Then I move my 2 hands a little bit forward and I stretch the rubber bands and quickly put them back on my forehead. And you report what you feel. And then you release the rubber bands, go forward and put it back on your forehead. In other words, what we're doing is stretching the rubber bands and allowing them to contract. And we are using our forehead as a temperature probe to tell us if we feel any changes in those experiments that we're doing. So this is, did you feel anybody want to say something to me? Did you feel a difference when you stretched and you put it? Yes, I can see some of you nodding. Yes, all right. So here's a related experiment. Take both hands like this and rub them very fast. What do you feel? You feel heat. That's because of friction.
I'm feeling heat.
So heat energy is what we're talking about right here. So we can do a lot of fun experiments this way. And on my website, scifun.org, in the upper left corner, you can click and download experiments you can do at home. And all of these experiments and many other experiments are described. Now, here's one of the experiments that I want to show you right now. Can you see what I have here? Is it washed out? Can you see? I have a sealed bottle. It has a liquid in it, and it has yellow beads on top of white beads in the middle. So this is what we call the mystery bead experiment. Why do we call it the mystery bead experiments? You know, in science, we like to solve mysteries. So let's see what happens when I shake the bottle. You can see that the beads have separated. The yellow beads went to the top and the white ones that went to the bottom. But you can also see they're moving back close together. So the mystery bead experiment is the one that we are talking about now. And it is described on the website under experiment you can do at home. You can prepare your own bottle. It takes a little bit of time, and you have to get the beads and follow the instructions, and you'll be able to do that experiment. So we'll do it again. So there is the same observation. And you can use different color beads. Here's the yellow on the bottom and blue on top. Let's shake and see what happens here. Isn't that cool? Yeah. So always think about what you observe, what you sense, and try to discuss it with others and try to learn from the conversation how you can come up with reasonable explanations that make sense. But always be aware that there may be some illusions, just as I mentioned before. All right, now I'm going to take, how are we doing so far? Anybody have any questions or any comments? Okay, we're doing all right. All right. So I have the glass of water that I used before, and I'm going to take an ice cube. Let me show you here. I want you to see what I'm doing. So here's the glass of water. And I take an ice cube and put it in the water. What happened? What do you see? Can you see the ice cube? Where's the ice cube? It's floating. Amazing. Not really, because we know this from experience. But we have to think about, why is it that ice floats on water? So I want to say to you that water is a unique substance. It's the only substance that exists in three stable forms: liquid, solid ice, and also water vapor. And water vapor is a greenhouse gas. We'll talk about greenhouse gases in a few moments here. But this experiment here relates to our understanding about one of the consequences of global warming. One of the consequences of global warming is that glaciers will be breaking off land and floating into the oceans. And of course, because they're made of ice, they will float. But the experiment that you should think about doing, and I'll say this very slowly so you can think about doing it, you take the glass of water like I did, and before you put the ice cube, you put a mark where the water level is. And then you put the ice cube in, and you'll see that the level of the liquid has gone up. And then you wait long enough until the ice cube melts. And when it melts, you'll be able to see that the level of the water is higher than before. This happens when glaciers are in the picture. If you think about icebergs, the icebergs are already in the water and floating. So when they melt, they don't contribute to rising sea levels. So this is an experiment that has to do with the properties of solid ice, the properties of liquid water, one property we call density. Density is the mass of the substance we have divided by the volume. So if the volume increases and the mass remains the same, then the substance is less dense. And if it's the other way, then the substance is more dense. So clearly, in this case, the ice cube is almost gone now, melted. Ice is less dense than water. Now, I have another glass here, and I'm going to put in it a different solid. This solid is dry ice. So I'm going to take some dry ice. Let me hold this so you can see it. And I don't want to drop the dry ice anyway. So here it is. So I put the dry ice in, and you can see that the dry ice is denser or more dense than the water. It goes to the bottom. And then we see bubbles. Those bubbles, oh, I love seeing your smiles like that. Those bubbles are carbon dioxide bubbles, and they're coming from dry ice, which is solid carbon dioxide. And when a solid changes to a gas directly without melting, we call that sublimation. Sublimation is happening right now, and we see it because the gas is mixing with liquid. When I have a chunk of dry ice, I'm going to reach here. I have the dry ice here. Sublimation is happening right there too, but we don't see it because gas is mixing with air, which is a mixture of gases itself. So dry ice is a very cold substance. Its temperature is minus 78 degrees Celsius, so we don't touch it with our bare hands. It'll cause frostbite, so that's not good. And now on the top of the liquid, we see the formation of a mist. It's the condensation of water vapor on the cold carbon dioxide gas that's coming from the sublimation. And that looks like fog or clouds, and that's what it is. Clouds and fog are condensed water vapor. And you notice, if you look carefully, that the condensed water vapor, the mist, the fog, is flowing downward. That tells us, if we didn't know it, that carbon dioxide gas is denser than air, heavier than air. So the carbon dioxide gas and water vapor are greenhouse gases. So can we look at the next slide, please, Bia?
Hey, Bassam, we have a question in the YouTube.
Oh, okay, you have a question before we
somebody
look at the
asked,
next? Yeah.
yeah, would the optical experiments like the arrows switching work the same if you used a different liquid like vegetable oil or another liquid?
Fantastic question. I like questions like that. And as long as you can see through the liquid, as long as you can see through the liquid, you can do that experiment. And this is how we learn. We ask a question and then we go ahead and do the experiment. I don't have any vegetable oil here to do it, but when we finish, doing experiments is fun all the time, not only when I'm doing it. They're more fun when you're doing them. So you try that experiment. And if you want to then tell me the result of your experiment, go to my website, scifon.org. At the bottom of the page, you can send me an email message and tell me what your observation is. So I would like to hear from you about that. So let's all do experiments together all the time.
Awesome. All right, I'll go to the slide.
Okay, these are the names and the chemical formulas for the major greenhouse gases: water vapor, carbon dioxide, methane, and nitrous oxide. You notice the representations: water vapor, H2O, there are 3 atoms, 2 hydrogen and 1 oxygen. Carbon dioxide, 1 carbon and 2 oxygen. Methane, 1 carbon, 4 hydrogens. And nitrous oxide, 2 nitrogens and 1 oxygen. These chemical formulas represent the composition of the substances we're talking about. And it's important to note that all of these greenhouse gases that I'm sharing with you here, in fact, all greenhouse gases have 3 atoms or more. And that's a question for some of us to think about and ask questions and ask, why is the statement that I'm making that if you have substance in the gaseous form that has 3 atoms or more, it makes it a greenhouse gas? Maybe we can discuss that. Maybe you can discuss it. Maybe you can try to find out why I make that statement. It has to do with how the atoms are bonded together, and it has to do with the structure of the different substances, the molecules that we're dealing with here. So H2O, water vapor, is a very significant greenhouse gas. By the way, greenhouse gases are good for us. If it weren't for greenhouse gases, the temperature on the surface of our planet would be close to the temperature on the surface of Mars, and life as we know it would not exist. So greenhouse gases are good for us. However, too much of anything is not good. More greenhouses is not good. The biggest culprit is carbon dioxide, and carbon dioxide comes from the combustion of fossil fuels that we use as sources of energy for transportation, heating our home, all kinds of different things. We burn gasoline, we burn fossil fuels, hydrocarbons, they're called. They have carbon and hydrogen atoms in them, and they have other things in them too. But when they burn, when we have combustion, they produce carbon dioxide gas. And carbon dioxide gas is a major greenhouse gas, and we can do something about that. We can try to reduce our dependence on fossil fuels as a source of energy. We can't do anything about water vapor because that's part of the water cycle. So let me then go on and ask you to look at the next slide, please. Because this slide, representing our state, gives us a telltale of global warming. Look to the left side. On the left side is a display of the plant hardiness zones between 1980 and 1999. On the right side is the display between 2000 and 2018. You can see that the zone color indicate to us a different display of how global warming is affecting climate change. So this is one important way by which we can tell that climate change is happening, and global warming is something we should be very, very concerned about and try to slow down. We cannot stop it. There are natural causes to global warming, but human activity since the Industrial Revolution has produced much, much more carbon dioxide in the atmosphere, as I will show you shortly. But in the next slide, I will show you also a telltale next slide, please, Bea. Excuse me. This is another indication of global warming. This is a display of the duration of ice on the surface of Lake Mendota. And you can see that from 1850 or thereabout till this year, the variations up and down, different years, very, but if you draw a straight line, in the best straight line in the information that is plotted here, you can see that the duration of ice on the surface of the lake is getting shorter and shorter. Ice off in the top graph, ice on in the bottom graph. And then, so this is another telltale. This is another indication that we have about global warming and its consequences, which is what we should be caring a lot about. On my next slide, I show you the amount of carbon dioxide that's in the atmosphere. The concentrations of carbon dioxide in the atmosphere measured on top of a mountain in Hawaii. And you can see that between 1960 and now, there is a significant increase in the amount of carbon dioxide in the atmosphere. The units of measurements here are called parts per million, and the increase has gone from about 315 parts per million to now 415 parts per million. This is a direct measure of how much carbon dioxide human beings and their activities are spewing into the atmosphere. And carbon dioxide is a major, major greenhouse gas that we need to be concerned about reducing its production by shifting to alternative forms of clean energy. And so that's why I talk to you about and share with you the importance of knowing something about these greenhouse gases. So let's pause now and see if anyone has a question or a comment. Do you have any questions or comments, Mia?
There's nothing else on YouTube right now.
All right. Does anyone want to ask a question before I then say to you that doing experiments is a lot of joy and a lot of fun. And it's important that these experiments be done obeying all the safety rules and being careful in using them. There's so many household items that we can use to do experiments. And on my website, scifun.org, there are experiments, as I mentioned, you can download and do them with others in the family and with your friends. They deal with what we see, they deal with what we feel. There are a couple of experiments that relate to smell. So I invite you to really enjoy doing home experiments and doing them safely. And that's why I would like to show you one such experiment now. If Bia would advance the slides, please.
We actually just got a question in, if you'd like to answer that first. The question is, what is the carbon dioxide concentration in the oceans compared to the atmosphere?
Very good question, because the carbon dioxide mixes with the ocean, and when it mixes with the ocean, it makes the ocean lower its acidity. So we use to represent acidic and basic properties of liquids, we use a pH scale. The pH scale is such that if the value is 7, then we have equal acid, equal base. If the value is above 7, then the liquid is basic. Below 7, the liquid is acidic. While the pH of the ocean is slightly above 7. And what is happening is when carbon dioxide is absorbed by the water, by the oceans, it combines and causes what's called ocean acidification. That is a term that we have to be careful about. The ocean water, the pH in the ocean is becoming less basic. It hasn't crossed over pH 7, but it's becoming less basic, slightly more acidic. And the consequences of that is that it affects, because of the chemical properties of what the shells in marine life are made of. They're made of calcium carbonate. And then there's a reaction between the carbonated water, the carbon dioxide that dissolves, and the shells. And it has severe and dire consequences on marine life. So it's a very, very good question about these properties. Okay, here's a video of the experiment that you can do at home. There's no sound that I'm sharing with you except what I'm talking. You take very common items, M&Ms, pour liquid in, and this is speeded up so we can see it happen. When you do the experiment, be patient about it. And isn't that cool? So this has to do again with solubility, with all kinds of different things. And you can visit my website on that last slide that well, you can also visit my website and look at videos that we have put together for home experiments and other experiments. And they are on YouTube. So go to scifun.org and click on the YouTube channel. It'll take you to what you see here. And then you'll be able to watch many of these videos. Some are short, 5 minutes, some are 10 minutes. Also, the full Christmas lecture is also on our YouTube channel. So the next slide, the last slide, this is how you go to the website, scifun.org. And I'm very pleased that so many people like doing experiments and like having fun because science is really, excuse me, intellectually stimulating, it's emotionally rewarding. So science is fun is not only a slogan, it is actually a philosophy of how we live and how we enjoy and try to learn more about the beautiful, complex world that we live in. So I also wanted to share with you, if you come back to me again, I want to go back and put a bigger chunk of dry ice. There we go. One thing we learned from this experiment is that carbon dioxide itself, the gas, is not very soluble in water. If it dissolved in water, we wouldn't be able to see. If a lot of it dissolved in water, we would not be able to see the bubbles. But some of it dissolves in water and causes what one of the questions was about, absorption and reactions of carbon dioxide gas with the oceans. It's interesting how the carbon dioxide gas we see here rises. It's interesting how the mist, the fog is formed on top. It's interesting how the fog flows down, reminding us that carbon dioxide gas, where the condensation of the water vapor is taking place, is denser or heavier than air. So all kinds of different experiments that we can do at home. If you do experiments with carbon dioxide, with dry ice, please be very, very careful because its temperature is minus 78 degrees Celsius. Always do the experiments with an adult. Always obey the safety rules. You notice I did not touch any of it with my bare hands. I used a spoon. So this is kind of a cool, neat experiment. And you can see I'm still here. It not just disappeared. So any other comments or questions?
Yes, we have a question from YouTube. Can parents or guardians purchase dry ice at grocery stores?
Yes, you can. At some grocery stores, you can purchase dry ice. This is where I got this one from. I'm not endorsing any of them, but you just ask your favorite grocery store if they have it. But then, because of its coldness, an adult has to get it.
And then a comment from our earlier question about the vegetable oil. This person says that they have a 16-ounce bottle of Crisco oil, and above the label is a circle of dimples in the bottle. And he says that the optics switch at the part where the oil bottle is smooth, but in the smooth round parts, but in the dimples, it doesn't switch.
Well, you have to be careful about where you position the liquid. Let me see. Where you position the okay. Oops, go this way. Yeah. You have to be careful how far back and close you are. So there's the answer to that from one person who did the experiment. I'm glad somebody did the experiment. And is the person still on or gone? how dark was the oil? Was it very dark or it was still visible? You could see through it, right?
We're still waiting for this person to reply, but
Okay.
he also commented a little later saying, I think I'm looking through two dimples 180 degrees apart, and maybe that's why the image is not switched.
Very good.
And then he just commented, it's transparent but yellow.
Yes. And speaking of oil, one of the experiments we have on the website is how to make a lava lamp. We have a video of that too. It's on the YouTube channel. It's pretty cool, actually. Oliver, Ollie, I'm on the phone. He's a good dog.
He just wanted to be part of it.
But he also wants to have fun too, right? So.
That's all the questions we have on YouTube.
All right. Anything else that anyone would like to ask? You can direct your questions to via email to the address at the bottom of my homepage, scifon.org. And we usually answer all the questions, relatively quickly. We answer all the questions except one. We will not do your homework problems for you. So thank you all very much for wanting to be part of science expeditions, and may every day in your life be full of joyful expeditions. So thank you for joining us, and I hope to see you in person sometime when it is safe for all of us to be together.
Thank you.
Thank you. Thank you. Bye.
Okay.
Bye.
Bye.